You're listening to Behind the Wheels with Doug Mason, Dave Walters, and Mike Yeagley. This is a show where we talk about heavy truck and medium-duty axle-ends. Doug, Dave, and Mike bring close to 100 years of experience and expertise in the transportation business. Join us once a month to learn new things about axle-ends. Sponsored by Alcoa Wheels, the global leader in aluminum wheel innovation.
Okay, welcome to another episode of Behind the Wheels. I'm Mike Yeagley.
And I'm Doug Mason.
And today we have three folks from Michelin here to join us in a discussion. We got Carl Remick, business model leader, Bill Walmsley, product category manager for tires, and Calvin Bradley, product category manager for aero. Hey, thank you guys for joining us.
Thank you, Mike. Thank you, Doug.
Yeah, very good to have you guys here. Again, just to remind you, we're live from TMC 2020. And so we're enjoying the show, and you guys obviously are showing what you've got here, and we're, again, very thankful that you guys are coming along to tell us more about truck tires and other things.
Well, thanks a lot for the invitation.
So I think everybody knows about Michelin, but let's go through it anyway. Tell us a little bit about Michelin and about yourselves.
Sure. Bill, I'll go ahead and start if that's
okay.
Cool with you. So my name is Carl Remick. I'm a business model leader for Michelin North America. I've been with Michelin for 27 years. We're often at TMC, really happy to be here and help in the education of the trucking industry, particularly as it relates to tires and solutions for our fleet customers. Happy to be here with Alcoa today. We're going to talk a little bit about the importance of low rolling resistance in tires to help meet greenhouse gas 2 regulations, as well as some aero technology that we have for trailers that helps with greenhouse gas 2 as well. Bill?
Yeah, thanks, Carl. Bill Walmsley. I've been with Michelin for about 10 years, in the trucking industry for about 20 years, and my role at Michelin is a product manager for the line haul tires.
And I'm Calvin Bradley. I've designed the Michelin Energy Guard system, which is our new aerodynamic for trailers. I've been working with Michelin, again, about 10 years, the whole time with an emphasis on fuel economy.
Okay, yeah, thank you guys very much again for being here at the show. And I guess what we start out with, Carl, is the greenhouse gas. If you give us a little bit about that legislation and kind of a bit of the impact, and we'll roll into some of the reasons the fleets need to be aware of this.
Right, some of the implications and how it relates back to the tires. So Bill and I will tag team this, but generally speaking, greenhouse gas 2 regulations, they drive a lot of the decision making that OEMs have to make when they're developing their tractors and bringing them to their customers in the market. And then there's some implications for the fleet customers that take delivery of those vehicles. So Bill and I will take you through a little bit of the implications of and the advantages of low rolling resistance on tires to help meet those regulations. Bill, can you add some color to that?
Just real quick, I'd like to just interject one thing here, is that there's a real tendency to think that the greenhouse gas thing is just a bunch of tree huggers, and there's no real value to the industry. But what we found is, at least what I'm seeing in the real world, is that greenhouse gases, it equates to fuel savings a lot of the time. When you reduce fuel, you're reducing the greenhouse gases. So, yeah, there's a little bit of tree hugger thing going on here, but the fact is that there's more to it than just that.
Yeah, absolutely. I mean, the direct benefit is to the environment, but to the fleet, if you reduce the amount of carbon output coming out of the truck, you're going to realize fuel savings directly.
What's the tire have to do with greenhouse gases?
There's a lot of inputs that the OEMs have to take into account to look at their carbon output for this greenhouse gas model that the EPA has put together. What it means to the tires is low rolling resistance tires will make a direct impact into reducing carbon emissions. So one of the easiest things an OEM can do to improve their greenhouse gas position is to put low rolling resistance tires on the truck.
When you say low rolling resistance, what does that exactly mean?
Generally, people in the industry relate that to fuel-saving tires or fuel-efficient tires, right? The tires that roll easier. The other dynamic there that is in conflict with that is generally when you lower the rolling resistance, people equate that to losing traction or wear in the tires. Now, they are in direct conflict, but the real win is when you can break the paradigm and improve the rolling resistance, meaning lower it, get the fuel savings, and either maintain or improve your wear, and also have tread designs that provide the traction that fleet drivers need.
So when I think of rolling resistance in a tire, I'm thinking about the energy that it takes to compress that tread.
Yep.
Primarily.
That's right.
It's the compression of the tread over and over and over, and all that energy that it takes to compress that tread is what's burning that.
Energy,
that's burning a hell of a lot of energy.
Right.
And so what low rolling resistance does is that you're actually reducing that tread compression, right?
That's right.
Okay.
So like a perfect tire in rolling resistance terms might be like a steel wheel rolling down a train track, for instance.
Right, not a whole lot of market for steel wheels for a completely 100% steel product out there.
Right. Yeah, the ride would be rough and you wouldn't have any traction.
Right.
And Mike, if I could add an explanation that I often use when I'm talking to customers is the natural correlation that people have in their minds is if I'm reducing rolling resistance, I'm somehow sacrificing traction, right? Because I'm making a more slippery tire.
Right.
And I like what you said about energy because that's where you have to focus. Every revolution of the tire requires energy. So you can make that tire more energy efficient, not only by reducing the coefficient of friction between the tread surface and the ground it's rolling on, but imagine the spring rate of a tire. As it rolls, it's flexing, right?
Right.
So if you can manage an efficiency gain in changing the spring rate, that deflection of the tire with every revolution, you can actually reduce rolling resistance, and you haven't touched any type of friction resistance between the tire and the ground. So when we work with our technical team, they look at all aspects of managing or reducing the amount of energy required to complete a tire rotation.
Okay.
And that's how you can actually get better fuel efficiency, right, without making the compromises on traction and tread wear. They are in conflict, like Bill said, but they're not in complete conflict. You don't have to rob Peter to pay Paul.
Right, right.
Now, are these material changes that are going on to do that? Obviously, to change the spring rate, you're looking at...
Right, you're looking at architecture, you're looking at materials, rubber compounding, and you're also looking at tread designs.
Okay.
So they work with those three things primarily. Bill might have some more details, but it's primarily in those three elements that the designers can reduce rolling resistance, make a more energy efficient tire, which helps reduce carbon emissions and helps the OEMs.
Another area that doesn't have as much of an impact on tread wear or on traction would be to take rolling resistance out of the casing itself. So we've been making some advancements there that, it won't sacrifice those other performances that fleets expect and drivers need, like traction.
So when you're saying the
casing,
when you're taking go into
so
that a little bit more.
that could be either in your belt packages. You could reduce mass in the belt packages. You can use more fuel-efficient rubber itself in the sidewall. So you're basically reducing mass in the sidewall or in the belts. Generally, you can reduce a certain percentage rolling resistance. Varies by tire, but you're not impacting your tread wear performance by doing those things.
Okay, yeah, and that's a little different than, and I really appreciate you going into that because I guess I was always under the impression that when you're burning energy in a tire due to rolling resistance, that flex was minimal.
Deflections
the contribution of the flex was minimal, and the majority of the energy burn was actually in that tread compression. But what I'm hearing now is that
it's the whole thing.
It's
the whole tire itself. Yeah.
Okay.
It brings up a question for me. I mean, I was just sitting in some retreading meetings earlier this week, and the question that comes to mind is for a fleet, obviously they have that casing, and they're going to want to reuse it a number of times. What is the impact on the rolling resistance as you start getting into a retreading process? Is it once you've used it initially, it really doesn't matter after that, or do you still same that gain advantage because of the casing?
The casing itself, actually, the tire, as the tire wears and it gets broken in, it gets more fuel efficient. One of the advantages of reducing the capability of the tire's rolling resistance in the casing itself is when you go to retread it, that fuel-efficient casing, if you put a fuel-efficient retread on it, you're still taking advantage of that in its second or third life.
Yeah, that's good. That's something I wondered about.
That's actually, I've never heard that before. That's really interesting.
Yeah. And, Michelin uses the same technology in our new tires, right? Rubber compounding, et cetera, as we use in our retreading, right? So you can buy a tread that's fuel efficient, and across the industry you can do that as well.
We've talked a little bit about the tire contribution for greenhouse gas. Is there any other component to this that we need to be thinking about?
Yeah, so tires is a contributor. I also like to use this explanation when I'm talking to fleet customers. Imagine your tractor trailer, it's rolling down the road. It has forces working against it as it's rolling down the road, obviously. So you've got friction between 18 tires, generally speaking, and the road. That's one contributor. You've got drivetrain friction, so all the friction between the moving parts that's powering that vehicle down the road. But the biggest contributor, by far over 50%, is the aero friction that it has to overcome as it's rolling down the road. So Michelin has gotten into that part of helping our fleet customers save money. And Calvin can talk to that, as he has been with us from step one to where we are now in offering aero solutions for trailers.
Okay, Calvin.
Aerodynamics is actually a lot like designing tires in that it is, again, another whole system where you can save fuel throughout the whole length of the tractor-trailer system. The tractor guys have been doing this for a long time, and modern tractors are amazingly aerodynamic efficient.
So when I think of aerodynamics in a tractor-trailer application, I guess I think of things as, correct me if I'm wrong, but mostly it's about reducing drag. It's about getting the air and having it slip over the surfaces and not getting caught behind things and pulling it back that way is what I'm, my simple understanding.
That's right. The goal is to not work by pushing the air around. So the smallest amount you can move the air as it goes around the trailer, the better.
So you want to get to that laminar flow. Engineering school, you have laminar flow, you have turbulent flow, and turbulence is actually causing all sorts of problems for everybody.
Yep, it just generates heat in the air, and that does no good for anything.
And anytime you see heat, you're talking about energy.
Yep, that's right.
Okay.
And for sure, at the back, at the trailer, there's always going to be air traveling with the trailer. So one of the goals for aerodynamics on the trailer side is if you have air moving with the back of the trailer, you want it to stay there. You don't want to have that slip away and be accelerated back, and then another part of air go in there. That's just extra work. You're just churning at the back. So the more you can stabilize the air that's moving with the trailer, the better.
That's why those boat tails work.
Yeah, so boat tails, and we have a system that does the same thing without actually extending off the back.
Okay.
So you can do it with intelligent design over the whole length of the trailer. Skirts are a part of that, but we found that what happens in one part of the system is going to impact what happens at the back. So a boat tail and a skirt, they may work well independently, but when you put them together, they may not work as you would expect. It's not an additive thing because it's working together as a system.
Right.
You got to have the complete package.
The
over
complete
whole
package
truck.
is how
Yeah,
you get
the
it.
whole
How you
truck.
get it all. Exactly. Exactly.
You know, I think it's probably a good time to take a break.
Okay.
Thank you, guys. I really appreciate you guys joining us. For our listeners, hope you enjoyed the discussion. We'll see you next time.
Thank you very much,
Thank you,
Mike.
guys.
Thanks,
Good day.
Doug.
Thanks a lot for coming, guys.
Sponsored by Alcoa Wheels, the global leader in aluminum wheel innovation, manufacturing, and technology. Inventing the first forged aluminum wheel in 1948, its team of experts continue to develop the most lightweight, efficient, and high-performing commercial vehicle aluminum wheel products. Bringing you revolutionary innovations like Alcoa DuraBrite wheels, Alcoa DuraBlack wheels, the new Alcoa Wheels hubboard technology, and the lightest truck wheel on the market, Alcoa Ultra One 22.5 by 8.25 wheel. Alcoa Wheels, the global leader in aluminum wheel innovation.